Okay, good morning, everybody. And today we're going to start to talk about visualization during exercise. So what do you need to know about this session? So first, what is aerobic or anaerobic exercise? Right, a different type of exercise in terms of using a different type of energy fuels and metabolize energy fuels differently. Um, and one type of exercise called aerobic exercise, which is the moderate intense exercise and undertaken for a long duration. For example, the marathon, right, running, a long distance and takes a couple hours. And the other type of exercise called anaerobic exercise is a high intensity and short-term exercise. For example, a 100 meter sprinting type of exercise, right? So there's two different type of exercise. Again, utilize energy fuels differently and metabolize energy fuels differently, right? And then we also going to learn exercise intensity. Usually we use VO2 max as a measurement of the exercise intensity. Um, and respiratory quotient or RQ is a measurement of a muscle exercise fuel utilization to tell us what type of energy fuel the muscle utilized during exercise, right? And also sources of energy fuel for exercise and fuel utilization, how fuels are utilized or metabolized in different type of exercise, aerobic versus anaerobic exercise or metabolism, right? And we're also going to learn fuel utilization during post-exercise recovery period. It can be also different, right, if we compare to fuel utilization during exercise. And muscle adaptation in response to training. So training can also change the fuel utilization and metabolism in the muscle. And lastly, we going to cover the carbohydrate loading or intervention to increase muscle glycogen, right? So before we talk about energy metabolism during exercise, the very important thing that we need to learn first is the muscle fibers, right? And this is a table I think is very important. Try to remember it, right? Try not to look at your notes, right? Look at the screen. So we have, in our body, we have three different type of muscle fibers. So type 1, see, type 1 fibers, which is the red fibers, and type 2A is also red fibers, and type 2X is white fibers. So based on the the color, you can see the white and red, and what makes this the color different? Can you guys tell me what makes? Hmm? Blood, yes, but some other things inside of cells, yes. Well, it's not quite. Very important for oxidative metabolism, mitochondria, right? So mitochondria, content. So the red fibers usually contain more mitochondria as compared to white fibers, right? So and relative distribution in an average person. So type 1 fibers, usually we have about 50% of fibers are type 1 fibers, right? And 40% of muscle fibers are type 2, and only 10% of fibers are type 2X, the white fibers, right? And then myosin ATP activities, it's slow in the type 1 and faster in type 2A and also faster in type 2X. This is something related to the ATP generation, right? So for example, the type 1 fibers, usually the slow twitch and slow oxidative, metabolism. So that means in the type 1 fibers, the ATP generation is relatively slow compared to the type 2X or type 2A, right? Depend on the function of a different type of fibers, right? We will get there, later, so you have a better understanding. And then the contraction velocity, also slow in type 1 and faster type 2A and slow in very fast in type 2X, right? The contraction, so it's also depend, and the function again, the different fibers. So in general, type 1 and type 2A fibers are used for long-term, exercise like marathon, right? And type 2X fibers usually used for very short, high intensity and very short term exercise like 100-meter sprinting. And the resistance to fatigue is also different in this three type of fibers. For example, type 1 fibers are resistant to fatigue. That means they're not very easy to get fatigue. But type 2X fibers, it's very easy to get fatigue, right? And type 2A fibers just in between, right? Intermediate. And then activities used for for metabolism. So type 2A, sorry, I apologize. I keep saying type 2A. So type 1 fibers usually use this aerobic metabolic activities, right? For generating ATPs. And type 2A, I utilize both aerobic and anaerobic metabolic activities, again, for ATP production. And type 2X only utilize an anaerobic metabolism, right, for ATP production. So and try to remember that most important characteristics of different fibers, and then that will be easier to understand the other characteristics, right? That is mitochondrial density or mitochondrial content. You guys already know, right? Type 1 and type 2A and red fibers, and so contain higher mitochondrial content. So particularly type 1 fibers, red fibers, have highest mitochondrial density content, and type 2A is intermediate, and type 2X have a lower mitochondrial content, right? So this characteristic, again, very important. Try to remember this first, and then you can just, easily to understand the others. Then let's see so you guys can tell me, right? Don't look at your notes, right? Just look at the screen. So the generated ATPs by what type of the metabolism, aerobic metabolism or anaerobic metabolism in the type 1 fibers? Aerobic or anaerobic? Aerobic, right? Yes. So aerobic system or metabolic activity, right, used in the type 1 fibers for generating ATPs. Again, because of a type 1 fibers has a higher mitochondrial content, so higher oxidative capacity, so you'll be able to utilize the anaerobic system to generate ATPs. And what about type 2A? Should use aerobic, anaerobic, or both? Both, right? So, still use aerobic system, but it's also be able to use anaerobic, right? So what about the type 2X? Anaerobic, right? Because they have a lower mitochondrial content, so not able to do much oxidative metabolism. So anaerobic system will be the major metabolic activities in the type 2X fibers, right, for ATP production, for energy metabolism. Okay, now the next item is the oxidative capacity. What do we expect type 1? Is high or low oxidative capacity in type 1? High, yes, right? It's correlated with, again, the mitochondrial content, right? And type 2A should be also intermediate or high. And type 2X should be lower, right? Again, it's lower mitochondria content. Okay, now what about the glycolytic capacity? What do you think type 1 fibers should have a higher or lower glycolytic activities? Glycolytic activity means that the glucose being metabolized through glycolysis will only stop at lactate, right? Will not be further completely oxidized. So what about the type 1 fibers? The glycolytic activities. Anybody? Should have low or high? Low, yes, thank you. Low, because it has a lot of mitochondria, right? Usually be able to completely oxidize glucose. So glycolytic activity in the type 1 fiber should be low. So this is also correlated with the high resistance to fatigue, right? So type 1 fibers usually produce less lactate because of lower glycolytic activities. And type 2A fibers is high glycolytic, and type 2X, of course, is high, right? And our next thing is creating phosphate content. Creating phosphate content in type 1 fibers. Do you guys know when actually muscle utilizes creatine phosphate as energy? We did not talk about, right, creatine phosphate when we talk about fat fasting and resting muscle. So usually under resting condition, muscle will not utilize creatine phosphate for the energy. So creatine phosphate is different from the other type of energy fuels. The creatine phosphate can very quickly generate ATPs, right? So thinking about it, the type 1 fibers or type 2 fibers, usually we use this type of fibers for relatively long distance, right? The running or long-term exercise. and we don't need to, not necessarily, need to generate ATP that quickly. But the short-term exercise, like 100-meter sprinting type of exercise, we need to make ATPs very quickly, right? Because the exercise only takes seconds. So what do you think will make sense? Which type of fibers will have a higher creatine phosphate content? Which type? Type 1, 2A, or 2X? 2X, yes, excellent. So 2X, right, should have a higher creatine phosphate content. So type 1, intermediate, type 2 high, and type 2X high creatine phosphate, right? All right. Yes, question.
I don't really understand why is that. So like why type 2X, why fiber would have a high phosphate content?
You mean why type 2X?
What is the reason?
Well, type 2X fibers because have a lower mitochondria, and that means that type 2X fibers were not able to efficiently utilize fatty acids for energy, right? So we need to use alternative energies, and glucose definitely is one of the energy fuels that type 2 fibers use. And the other thing is important because of type 2 fibers usually involved in the very short-term high intensity exercise. So that means they need ATP immediately, very quickly, So this makes the type 2 fibers also need creatine phosphate as alternative energy. So again, type 2X fibers requires creatine phosphate and glucose for ATP production. And the other two type of fibers, because they have a relatively higher mitochondrial content, they will be able to use fatty acids for energy. And this type of 1 and 2A fibers also that involved in the long-term, relatively long-term exercise or like a marathon, right? So, need of ATP not that as quick as 100-meter sprinting type of exercise, right? And okay, so next one is glycogen content. Glycogen content. So thinking about these three type of fibers, which type of fiber you think they will rely on more carbohydrate for energy? Yes, short term, right? The type 2X. So type 2X fibers should have a higher glycogen content or need a high glycogen content, I would say, right? Because, it heavily relying on glucose, carbohydrate for energy. And the type 1 and 2A fibers, because they are able to use the fat, so they probably also need glycogen, but not, as much as type 2X. So again, the glycogen content will be very high in type 2X fibers, but intermediate in the other two type of fibers, right? And last one is a triglyceride content. What do you expect? I would ask, what do you expect? Which muscle fibers should have a lower triglyceride content? 2X, yes, because you're not able to utilize, right, fatty acids. So, that makes sense, right? The type 2X would have a lower triglyceride content, and type 1 particularly have a higher, triglyceride content. Right? Any questions? Yes.
Could you repeat what you said about lactate and which fiber
Right,
And
right.
just-
So, and this also will correlated with glycolytic activities, right? So 2X, fiber 2X will have a higher glycolytic activity again because of a lower mitochondria. We're not able to utilize fatty acids and utilize glucose, but only partial oxidized, right? So in type of 2X fibers, so a lot of lactate will be generated. So lactate concentration is the cause of the, it's related to the fatigue, right? Okay, now let's go to the details and talk about each type of fibers. And so why we should know about the muscle fibers that I just explained, right? In our body that we have 3 different type of fibers in the skeletal muscle, and different type of fibers utilize have a different metabolic characteristics, right? And utilize different type of energy, and also involve a different type of exercise. So that's the reason that we need to understand, better the muscle fibers. And type 1 is again is a slow twitch fibers and has a high mitochondrial content and a higher oxidative capacity, right? So usually does do the aerobic metabolism, especially fat oxidation. You have a question? Yeah.
If you do, say you run marathons quite often, or you do a certain type of exercise more often, can you kind of manipulate if you get more of those types of fibers? Like, would it?
What is?
Make sense?
Yeah. We will get there later, right? We'll get detail. As we talk about aerobic and related to marathon, and talk about the anaerobic related to the 100-meter sprinting, and then we talk about detail on how energy would metabolize, how fibers will be recruited during the different type of exercise, right? Yeah, you have a question?
So when you say high oxidative capacity, just so I'm clear, this means it will go all the way through the TCA cycle. It'll be completely oxidized.
Correct.
Low lactate.
Correct. Yes. Because mitochondria, have a lot of mitochondria, so mitochondria be able to do this. So yeah, it's oxidative capacity correlated with mitochondrial content, right? And so type 1 fibers usually is suited to perform endurance exercise, for example, marathon, right? And the reason, because marathon usually, takes a couple hours, right? More than 2 hours is a long-term exercise, and the energy, in terms of energy utilization, the muscle glycogen content usually is kind of limited, right? The glycogen store is not able to meet all the energy requirement during the whole exercise period. So that means muscle need to utilize a different type of energy source, particularly fat, for energy. Yes.
So is that true for everyone? So somebody that runs marathons all the time versus somebody that never runs at all,
Mm-hmm.
is it different? I mean, are they?
Yeah, great question. Yes, they actually different. In terms of the distribution or composition of different type of fibers, that marathon runners should have a high percentage of the type 1 fibers.
So someone that like doesn't run very often would get out of that stage
Mm-hmm.
much more quickly than.
Right. Yeah. So I think that we also have we're going to talk about this later. So how training will change the muscle fiber composition and metabolism, right? Okay. So and the question for type 1 fibers is how is glucose metabolized in type 1 fibers? What do you guys think? Partial oxidation or complete oxidation? Should be most of the glucose, right? Should be complete oxidized in the type 1 fibers. So that's the reason type 1 fibers usually generate less lactate, right? Okay, so the next type is 2A, type 2A fibers, which is fast switch and modulate oxidative capacity because of they have a higher, still have a high content mitochondria, but a little bit less compared to type 1, but have a more compared to type 2X.
How is glucose metabolized in type 1 fibers?
Sorry, what you say?
Could you repeat how is glucose metabolized in type 1
Oh, in the type 1 fibers, it's a complete oxidation. Yeah, most of the glucose complete oxidation. Okay, so type 2A is as a moderate oxidative capacity. So they can do both aerobic metabolism and also anaerobic metabolism, right? Because type 2As also have a higher glycolytic capacity. So, type 2A fibers is suitable for middle distance running or swimming type of exercise, right? Type 2X is faster twitch and low oxidative capacity because of lower mitochondrial content, but very high glycolytic capacity also due to the lower mitochondrial content. So glucose cannot be completely oxidized and usually just, partial oxidized, right? So very high glycolytic activity and produce a high levels of lactate. So this type of fibers usually does the anaerobic metabolism, right? And because of the, the glucose is metabolized in type 2 fibers, and well, actually, I can ask you first, right? How glucose is metabolized in type 2 fibers? Partial or complete in type 2, partial oxidized, right? So produce a lot of lactate. Again, lactate mostly produced by type 2X fibers, right, in exercise. And this type 2X fibers usually is specialized to perform a sprinting exercise, very short term exercise, sprinting exercise. Okay, any questions? Right. So during the like pro-run exercise, for example, marathons, at the 60 to 75% of oxygen VO2 max, we're going to talk about later, right? The exercise intensity. So type 1 fibers and type 2 fibers are recruited during the early stage of exercise, during running the marathon, for example. And the very early stage, then these two type of fibers, type 1 and 2A fibers are recruited and then involved in the, in the metabolism and metabolize and oxidize the energy fuse and generate ATPs for exercising, right? And as exercise prolongs, and type 2 fibers, and then recruited, so at a relatively later stage, right? So and type 2 fibers then recruited and then involved in the the metabolism. So that and again, because of a type 2 fibers usually produce lactate, right? So that is so that's why at the later stage then you runners feel kind of fatigue, muscle fatigue. So that because of type 2 fibers that involve and produce lactate, right? All right. So let's talk about more the different type of exercise, aerobic versus anaerobic. Oh, question, yes.
Sorry, I'm confused about
Mm-hmm.
type 2X, because on one side it says it's just for short term,
Right.
but then on the left side it said that you don't prolong exercise activity too, so I'm confused, I guess, when.
Okay, yeah, that's a good question. So in basically, like very short term exercise like sprinting, the only must only you use is the type of 2X for energy metabolism, right? But it is also actually involved in the like the I just talk about the long term exercise like a marathon, but at the very later stage, when the other type of fibers that utilizes all the energies that muscle can provide. So the type of 2X fibers and start being used to generate energy to maintain the same intensity of exercise at just a very short and at a very later stage of the long-term exercise.
If you use that like for somebody running a marathon, when they just start the marathon, are they using type 2X and then later?
No, the beginning, the early stage of a marathon, they usually use the type 1 and the type 2 fibers, type 2A fibers, and then a very later stage, the exercise intensity goes lower, and in order to maintain the the activity and intensity, then type 2 fibers join in and start to work, and try to make the ATPs. Yeah, question. Oh,
So at the beginning of a marathon, do you not use your glycogen stores right away? Or do you?
yes, use the glycogen. Yes.
Wouldn't that be, so I still don't understand why 2X comes later and not right at first.
It could because there's like a difference in energy intensity. Does that have to do with like what fibers are used? Like if it's not sprint, if it's like less intensity to start, because you don't start a marathon at full
Right.
speed.
Correct. Yes, yes. Yeah, okay.
So I'm just wondering, like with glycogen stores, like we were asking about, if you run out of glycogen stores and you get to this point where, glucose is kind of running low and you're utilizing, fat for oxidation and
Mm-hmm.
keeping your energy up. So
Right.
the type 2X fibers, are they just kind of trying to keep up by producing lactate to make up for the glucose that's not there? Or is it?
Yeah, that's good thought. I think that could be the reason, one of the reason. But I will tell you actually, later. I mean, the exercise when the intensity is increase, like you talk about it, the relative later stage, that fat utilization actually decrease. The muscle, the ability to utilize fat is decreased. So then muscle need, to use to keep in order to keep intensity. So different type of fiber then will join in and then use a different type of energy source and to maintain the intensity of the exercise. Does that make sense? Yeah.
So does the muscle have an ability to kind of hold on to glycogen? So if you're running a marathon, your body just knows like to hold on to some of that glucose storage
Mm-hmm.
because you might need it later on. Do you know what I mean? Like you don't spend it all at the beginning. Because it has to kick in later when you're no longer able to do fat oxidation. Like
Right.
glycogen store help you out later.
That's good thoughts. Right, right. So remember that actually a couple of things. Uh, type of 2 fibers have a higher glycogen content, right? And type of 1 and 2 relatively lower uh, glycogen content, but higher oxidative capacity, so it'd be a higher triglyceride content. So type of 1 and 2, you did first. This, like you said, I mean, the type of 2 fibers just kind of store, the glycogen and utilize later. So the type of 1 and type of 2A fibers and start working first, right? And once these 2 fibers utilize almost all the, energy source like glycogen and fatty acids, and plus these 2 type of fibers, the ability of these 2 type of fibers to utilize fat is actually decreased at the later stage. So at the very later stage, and because of these 2 types kind of get exhausted, right, and almost no have no energy sources available, or use up all the energy sources. So then type of 2 fibers start to um, to be active, and then to make the muscle intensity, maintain the intensity of a muscle, and to make sure that exercise can continue at similar levels of intensity or activities. Right? Does that make sense? Okay. Yes.
So it really has to do with the oxidative capacity, because type 1 and 2A have high oxidative capacity, so they can go through the TCA cycle.
Right.
Create a lot of ATP, but then that'll eventually run out.
Correct.
That's why 2X goes in.
Correct. Yes. Yes. Yeah. Yeah.
I'm just wondering, are you gonna explain at all about, like, you were saying something about oxidative capacity or reaching a point of where you can't really utilize fat like you were in the beginning, kind of that mixture of fat and
Mhm.
carbohydrate.
Mhm.
You reach a point where you have to start creating lactate, and that's where you kind of fatigue and you lose pretty much your
Right.
bonk if you're running a marathon.
Right. Mhm.
Is that gonna be explained in the lesson, or is that something?
Yes, yes. I mean, the later I think we will explain this. We have some content to cover this kind of question issues. Yeah, yeah. That makes sense. Yeah. All right. So aerobic exercise basically, yeah, very good discussion. Thank you, guys. So aerobic exercise. Again, is involved in the long-term exercise, right? And most important thing is, or the most important characteristic of aerobic exercise is use of oxygen, right? So oxygen is needed. Both actually oxygen and mitochondria are needed for aerobic exercise. Right? So, and again, only type 1 and type 2A fibers are be able to do aerobic exercise because of mitochondrial content. And anaerobic exercise basically is usually occur in the short-term and high energy required exercise, for example, 100 meter sprinting, right, just for like 10 seconds. And this type of exercise is usually, and in terms of energy metabolism, is usually anaerobic. So why is anaerobic? Do you guys can think in more? Why? 100-meter sprinting is anaerobic exercise and not aerobic exercise. I just said, right, oxygen is required for aerobic exercise. Why? Mitochondria is one thing, and the oxygen is the other thing, right? Why, like 10 seconds, 100 sprinting meter exercise is anaerobic. Yeah.
It has to do with we can't get oxygen there fast enough for these activities, so we have to access something quicker.
Wonderful. Yes, yes, great. So because of oxygen cannot be transported quickly enough to the skeletal muscle, right, to do the aerobic exercise. So only 10 seconds. So this is the most important thing, the reason that why 100-meter sprinting is an anaerobic exercise, right? Okay. Um, Let me see. Do you guys want to take a break? Sure. Okay. Yeah. All right. All right, guys. Okay, now let's talk about exercise intensity. So how to define exercise intensity? So exercise intensity basically is determined by muscle contraction cycles per unit of time. You know, if the higher the exercise intensity, the more contraction cycles, right, are needed per unit of time. So that should be easier to understand, right? And more ATPs are needed, right, per unit of time, and more fuel is needed for oxidize. So again, the high intensity exercise, you should have more contraction cycles per unit of time, and you also need more ATPs to be produced and within this time period, per unit of time, and more energy fuels are needed. So in general, the rate of ATP synthesis and fuel oxidation in muscle are increased during exercise. I'm talking about the long-term exercise, right? The intensity as you gradually increase. So then you need more ATP, you synthesize and oxidize more energy fuels during exercise in order to maintain the the same levels of exercise performance. Okay, so we usually use the called VO2, V oxygen maximum, volume oxygen maximum as the measurement of exercise intensity, because of in order to produce ATPs and oxidize energy fuels, you need the oxygen, right? So oxygen, how much oxygen is consumed, that related to the how much oxidation is happening, or how many ATPs produced, right? So if you oxidize more energy fuels and produce more ATPs, then you require more oxygen, right? So you use oxygen to measure the exercise intensity. Does that make sense, right? So everyone has the maximum oxygen, oxidative capacity. Maybe different individuals have a different number, but each individual should have its own maximum capacity. So if you compare the athletes, and they probably, particularly marathon runner, they probably have a higher oxidative capacity compared to the non-tradition, what I should just call it, untrained runners, right? So these numbers you guys wanted to remember as the energy expenditure, or the percentage of VO2 max. Remember these numbers, right? Sorry, these numbers. The which percentage of VO2 max correlated to the what type of the intensity of exercise, right? So for example, doing low intensity of exercise, the faster walk, this type of exercise considered a low intensity exercise. Usually you only use 25% of your maximum oxygen consumption, right? And moderate intensity type of exercise like jogging, fast jogging, usually you only use 60% of your maximum oxygen capacity. And the high intensity, like 2-hour, marathon running, usually you uses 80% of maximum oxygen consumption or oxidative capacity, right? Try to remember this percentage, right, and correlate it to the intensity. So oxygen is also linear. Oxygen consumption is also linearly related to the energy expenditure. This I already explained, right? Explained, you oxidize nutrients require oxygen. So if you burn more or oxide more nutrients, particularly fatty acids, that you need more, utilize more oxygens. So oxygen again, linearly related to energy expenditure. So higher oxygen consumption, higher energy expenditure. And greater consumption of oxygen is also related to the greater intensity of exercise, right? That also makes sense. And training usually can increase oxygen consumption, right? Increase the maximum aerobic capacity. After training, your VO2 max will be increased, right? So you have increased your oxidative capacity. So you'll be able to utilize fatty acids for energy during exercise, which is very important, right, in order to increase the performance of the exercise. So again, training can increase the VO2 max and increase oxidative capacity. So that's why I explained to you, right, the marathon runner versus unchained runner, they have a different oxygen, capacity, right? Oxygen consumption, oxidative capacity. So usually training can increase the VO2 max by about 15 to 20%, right? All right. Any questions? Okay. So now let's go back to talk about fuel utilization in skeletal muscle during the resting state. I think we mentioned this before, right, when we talk about fuel utilization in response to food intake. And the fuel utilization can be different between resting state and exercise. So resting state, muscle usually utilize glucose in the fat state, right? So in the fat state, muscle, most of the energy fuel that utilized by muscle is glucose. And during fasting condition, muscle utilize more fatty acids, right? But during the exercise, muscle utilize both carbohydrate and fatty acids, right? And again, during the resting condition, the blood-borne fuels are the primary source, right? Blood-borne fuels are the primary source of energy during the resting condition for muscle. For example, the plasma or blood glucose basically is from diet, right, in the fat condition, and can also from the liver glycogen breakdown during the fasting condition. And also liver can make a glucose, right, through gluconeogenesis to contribute energy for muscle. So again, blood-borne fuel are the primary source of energy. And plasma, in terms of fatty acid during the fasting, most of fatty acids is come from which tissues during the fasting? Adipose tissue, fat tissue, right? And also triglyceride can be released from liver during the fasting condition, right? Although the initially fatty acid in the triglycerides is from fat also, right? So again, during the fasting condition, fatty acids plasma fatty acids or blood fatty acids are the main sources of energy for the muscle. And try to remember intramuscular fields are not important for the energy need of a resting muscle. Intramuscular fields, for example, muscle glycogen and muscle triglyceride. So during resting condition, these two type of intramuscular energy fields, muscle glycogen, muscle triglyceride, are not the main, not an important energy source for muscle, right? So muscle again utilize energy source glucose fatty acid mostly from diet or in the fat condition or from the liver glycogen breakdown or fatty acids from adipose tissue, right? Does that make sense? So the sources of energy is different between resting condition and exercise for the muscle. Now, how about fuel utilization in muscle during exercise? So during exercise, muscle be able to utilize carbohydrate, fatty acids. Oh, can I go back to the actual resting state? I don't think I listed low down here. Actually, remember one of the other important sources during fasting, energy source, energy fuel during the fasting condition muscle can use. Yes, ketone bodies, right? Don't forget ketone bodies, right, for the resting. Oh, did I include ketone bodies? No, no. Ketone body, I don't see ketone body there, right? So try to add the ketone bodies, right, during the fasting. Yes.
So then, during the resting state, then the blood-brain flows are going to be the main source of energy.
Yeah, yeah, yeah.
And when you say the intramuscular flows, those are the fatty acids and the glucose. So like glucose in the fat state and fatty acids.
Right. Fatty acids, ketone bodies, right? Okay. So again, blood-brain fuels for resting muscle includes glucose, fatty acids, and ketone bodies, right? Now, how about during exercise? We don't see the ketone bodies. Hmm?
Say glucose, fatty acids, and ketone bodies is also important during the resting muscle.
Right. Resting state.
And they are also important for the exercises during exercise too.
Ketone bodies? No. Then now let's talk about.
Okay, ketone bodies is for not exercise, just resting.
Right. Just resting. So don't forget ketone body, right? We muscle utilize ketone bodies during the resting condition, during the fasting, right? Resting condition. Now during exercise, carbohydrate, fat, and most important, not most important, right? Another important energy source is the muscle creatine phosphate, right? These are the energy fuels used by muscle during exercise, and we do not see ketone bodies listed here, right? So ketone bodies is not the important fuels for exercise, right, for the muscle. Again, exercise muscle utilizes carbohydrate, fat, and the muscle creatine phosphate for energy. And muscle creatine phosphate is not an important energy fuel for muscle during resting condition, right? That makes sense, okay? So carbohydrate can include blood glucose that can be from diet and can also be from glycogen breakdown. So And muscle glycogen and liver glycogen, right, are also important sources of glucose for muscle use during exercise. I put the muscle glycogen before liver glycogen because muscle glycogen is more important for exercise muscle compared to liver glycogen, right? And fat can be free fatty acids in the circulation or triglyceride in the circulation, right? And intramuscular triglyceride, right? So sources are different, you know, if we compare resting muscle to exercise muscle, right? And muscle creatine phosphate is also in the energy source for exercise muscle. So the energy cost of working muscles, so muscle shortening and movement also definitely requires energy, right, from the hydrolysis of ATP and by the ATP, different type of ATPase. So ATPase basically break down the high energy phosphate bond and release energy from ATP molecules. And the body uses about half of the skeletal muscle mass for running a marathon, and this is something is important to help us to understand why muscle will use fat for energy when we sprint later, right? Just keep in mind, and when we're running a marathon, only half of a muscle you use, or half of muscle is involved in the exercise. So most of required ATP for a marathon is produced by aerobic oxidation of both carbohydrate and fatty acids. But most of ATP for 100-meter sprinting is produced by anaerobic metabolism, right, of muscle creatine phosphate and glycogen. So the sources of energy fuels for different type of exercise, again, is different, right? For marathon and long-term exercise, aerobic exercise, carbohydrate and fat are the most important source of energy. And for 100-meter sprinting, anaerobic exercise, creatine phosphate and glycogen are the important energy source, right? And this is just show you guys how ATP is produced. When our muscle metabolize glucose and fatty acids and produce ATPs, and ATP then being hydrolyzed by the 3 different type of ATPase and break down the high energy phosphate bond, right, and to release energy, and this energy basically used for muscle fiber shortening and movement, and also polarization, depolarization of muscle cell membrane. And the calcium release is very important, right, to trigger the muscle contraction. So all this activities require ATP's energy, so energy generated for the use of all this type of activities in the muscle cells, right? All right. Okay. So sources of carbohydrate, fat for oxidation in skeletal muscle, and just give you a little bit detail. The energy source. For example, during aerobic exercise, muscle. Again, I have just try to test you. During aerobic exercise, which type of fibers that involved? Which type of fibers involved? 1 and 2A, yes. 1 and 2A, right, involved in the aerobic exercise. And glucose fatty acids are used for ATP production. And what about creatine phosphate? What creatine phosphate is used for aerobic exercise? No, right? Okay, so only glucose and fatty acids are used for aerobic exercise, right? And glucose basically has two different sources. One is blood glucose, right? The blood glucose basically from diet or from glycogen breakdown. And the other source of glucose is muscle glycogen breakdown, right? So again, muscle glycogen breakdown is most important sources of glucose for aerobic exercise. And fatty acids. So fatty acids also have three different sources. The first is circulating fatty acids. Initially can be from dietary lipids, and can also be from triglyceride breakdown, right, from the adipose tissue. And triglyceride in the circulation in the VLDL can be transported to the muscle from liver to the muscle, right? This can also be one of the sources of fatty acids. And lastly, the intramuscular triglyceride, right, breakdown is also the important sources, right? Again, during the resting muscles, muscle glycogen breakdown and intracellular triglyceride breakdown is not that important, right? And this diagram just gives us a better idea, a picture, how different sources of energy that being used for muscle. So two questions you guys probably wanted to ask yourself is, where does glucose used in muscle come from during aerobic exercise? Right? Again, the muscle glycogen is a major source of carbohydrate. And the second question is, how is glucose metabolized during aerobic exercise? Again, different type of fibers that metabolize glucose differently, right? Try to remember this. And in terms of sources of glucose, so first, glucose is from diet, right, and into the circulation, and then be picked up by muscle and utilized as energy. And the second source is the glycogen in the liver can be break down, and glucose can be used in the muscle, right? And most important sources of glucose is the glycogen, muscle glycogen, right? So muscle stored about 350 to 800 grams of glycogen in the muscle that can be break down and utilized for ATP production, right? And three different type of fibers that glucose metabolize in three different fibers differently. So what about type 1 and 2A? How glucose is metabolized in type 1 and 2A? It should be complete oxidized, right? Should be the aerobic metabolism, goes aerobic metabolic pathway and complete oxidized. And type 2X fibers basically is anaerobically, right? Is a major sources of lactate, in the muscle. All right. Now, this is the sources of fatty acids, right? Oxidation during the exercise. And similarly, two questions that you want to ask: that where do fatty acids used in muscle come from during aerobic exercise, and how are fatty acids metabolized in during the aerobic exercise, right? So first, during exercise, an important thing happened is that catecholamine levels actually increased. So catecholamine is most important hormones during exercise that regulates all the energy metabolism, right? So catecholamine can stimulate adipose tissue to break down triglyceride and release fatty acids into circulation. This is the most, not to say most important, but it's one of the important source of fatty acids, right, from fat tissue, and then uptake by muscle and utilized for energy. And secondly, the sum of fatty acids that released from fat tissue will not completely uptaken by the muscle, right? So you have kind of leaky fatty acids that can go to the liver and packed into, reacidified triglyceride and packed into VLDL. So VLDL then can take these fatty acids initially from fat tissue into the circulation, and muscle has its own LPL, right? And this LPL basically is increased during exercise and stimulated by catecholamine, norepinephrine. So LPL hydrolyzed triglyceride and VLDL to fatty acids, and this fatty acid eventually also go into the muscle, right? And last, also very important, sources of fatty acids is intramuscular triglyceride. So triglyceride, muscle also has some triglycerides stored in the muscle, right? So this will serve as an important energy source during exercise. It will be breakdown and utilized, right, for energy production. And here is a question. So how type 1 and type 2 fibers oxidize, metabolize fatty acids? I mean, all the other, I just ask a different question. So can type 1 and type 2 fibers be use fatty acids for energy? Yes or no? Yes, right? Okay. And should be, fatty acids should be complete oxidized, right? In these two type of fibers because they have a mitochondria, right? Does that make sense? And what about type 2X fibers? Is type 2X fibers able to use fatty acids for energy? Yes or no? I saw Rolla. No, right? You said no. So because of again, lacks of mitochondria, right? Or not, because not 100% lack. I mean, the type 2 fibers have less mitochondria, so have a lower oxidative capacity. Okay. Any questions? Yeah.
Utilization of fatty acids in type 2 fiber is limited. Relax mitochondria what? No or yes?
No.
No.
Type 2 fiber type 2X fibers are not able to utilize fatty acids for energy, right? Because of lower mitochondrial intensity or capacity. Yes.
Are they not able to use fatty acid at all, or just at a much slower rate?
Say that again. Sorry.
Are the type 2X able to use fatty acids at all, or just at a much slower rate?
That's a good question. So I would say not like 100% no, but maybe be able to utilize some of fatty acids, like because of again low mitochondria, right? And actually, type 2X fibers, mostly is involved in the the anaerobic exercise, like 100 100-meter sprinting. So, and during this type of exercise, the type of 2X fiber definitely will not use fatty acids for energy, right? It takes time. So, because 10-second type of exercise requires ATP production very quickly, right? So definitely we're not able to utilize fatty acids for ATP production. But during the long-term marathon type of exercise, remember we also mentioned the type 2 fibers were also involved, right, in the later stage. So during the marathon, although it's not most important fiber that, for this type of exercise, but maybe involved a little bit. So during this type of marathon exercise, the type 2 fibers maybe utilize, a little bit fatty acids, but, at, like you said, at a very slow rate, right? But again, type 2 fiber, type 2X fibers, even during the marathon exercise, will still use mainly use carbohydrate, glycogen as an energy. Right? Any other questions? Right? Let's see. What's next? So as I mentioned, that aerobic exercise requires both oxygen and also mitochondria content, right? So in order to maintain the aerobic metabolism, that our body has to adapt to increase the oxygen consumption, right? Oxygen consumption, and also increase the mitochondrial content. That will happen in during the training, but in general, for the aerobic exercise, in order to perform aerobic exercise, we need increased oxygen delivery, right, to the skeletal muscle. So there are couple of activities or physiological, activities our body can do is to increase oxygen delivery to the tissue, to increase oxygen capacity. And this includes increase heart rate and volume, right? And increase the breathing rate, and then finally increase the blood flow to the muscle, right? This is very important, the adaptation during exercise, right? So we need to increase the heart rate, the volume, and increase the breathing rate and blood flow to the muscle. The purpose of this is to increase oxygen delivery, right, to the muscle to allow the, oxidative metabolism occur. Right? Any questions? Okay, so so last thing we have informal writing, right? Let's do something. Okay, so for this last informal writing, right, and try to describe the differences in the metabolic characteristics of type 1 and type 2 X fibers, and try to focusing on the mitochondrial density, oxidative capacity, glycolytic activity, and anaerobic system that used for ATP production. And also, lastly, what type of exercise activity used for the energy production. Right?